Hello everyone, hope you're having a good day. Here is your lesson for Chapter 5, Lesson 5, Graphs of Proportional Relationships. Your learning target for this lesson is to be able to represent proportional relationships using graphs and equations. And your success criteria is to be able to determine whether quantities are proportional using a graph, to find the unit rate of a proportional relationship using a graph, and to create equations to represent proportional relationships. Graphs of proportional relationships. Two quantities, x and y, are proportional when y equals k times x, where k is a number and k is not equal to 0. The number k represents the multiplicative relationship between the quantities and is called the constant of proportionality. The graph of y equals k times x is a line that passes through the origin. Two quantities are proportional when the points create a straight line that passes through the origin, point 0, 0. So this is your summary of what all that stuff up top said. So let's take a look at a few examples. In this first example, A, it says plot the points and draw a line through the points. So we're graphing x at 1 and y at -2. So we'll go 1 to the left and 2 down. We'll go 2 to the right and 0 up. 3 to the right and 2 up. 4 to the right and 4 up. So there's our graph. We can see that that is not linear. And it's not proportional. It's not linear because it isn't a line. And it's not proportional because the line or the graph does not go through the origin, 0, 0. You can also see up here in the table does not contain the point 0, 0. So with that being said, just by looking at the table in example B, you can tell immediately that this is proportional if it's linear. So let's graph the points. 0, 0, 2, 2, 4, 4, and 6, 6. It is linear. It's a straight line. It is proportional because it goes through the origin 0, 0, and because the table has the point 0, 0 right there. Now you try it. Tell whether x and y are proportional and explain your reasoning. Start by graphing each of these tables on the graph below. Then when you're ready, push play and I'll give you the explanation for why it's proportional or not, as well as whether each of these functions is linear or not. All right, for question number 1, we start with the point 0, -2, 1, 1, 2, 4, and 3, 7. So while it appears that this is a linear expression, this graph does not go through the origin, the point 0, 0, so therefore we would say this is not proportional. Question number 2, I had to change the scale a little bit because we're jumping by 4s. So please notice that I stayed consistent in my intervals though. I did increase by 4 each time, going both up and down, positive and negative. So now we'll plot the points 1, 4, 2, 8, 3, 12, and 4, 16. That is both a linear expression and it goes through the origin, the point 0, 0. So we would say, yes, that is proportional and we would say it's linear. For question number 3, let's plot the points -2, 4, -1, 2, 0, 0, and 1, 2. So here we see that we do not have a linear relationship. However, our point does go through the origin. So remember, it has to be both. It has to be linear and it has to go through the origin. And in this case, it's not linear. So we would say that we know that it is not proportional. In example number 2, we're given a graph that shows the subway car's speed. And it says to find the unit rate from the graph. The graph shows the speed of the subway car. Find the speed in miles per hour. So one way we could think about this is we could look at the point 1, 1/2. 1 in this situation is minutes, and 1/2 is how many miles are traveled. So we could say that the speed of the subway car is 1/2 miles per minute. And that is a unit rate because we have per 1/2 miles per minute. Another way that we could look at this is by looking at the point 2, 1, where in this case 2 is the time in minutes and 1 is the miles. So here we have 1/2 miles per minute, or 1/2 miles per minute. So the next question becomes then, what if? Does your answer change when you use the point 1/2, 1/4 to find the speed of a subway car? And explain your reasoning. So the way we would set this up is actually just by creating a complex fraction. We will have 1/4 which is distance, divided by time, because that's the equation for speed. So we have 1/4 divided by 1/2. 1/4 divided by 1/2 is the same as 1/4 times the reciprocal, which is 2/1. Cross simplify, and you get 1/2, which is 1/2 mile per minute. So it doesn't change it at all. And the reason it doesn't change is because our function is linear, so it's got a constant rate of change. In this example, it asks to identify a proportional relationship. Use the graph shown to tell whether x and y are proportional and explain your reasoning. So right away, we can tell that this is proportional. It is a linear function, meaning it goes up in a straight line, and the graph goes through the origin, which is the point 0, 0. So we would say, yes, it is linear and it is proportional because it goes through the origin. Interpret each plotted point in the graph and then identify the unit rate. So 0, 0. That means 0 inches in 0 seconds. The point 1, 1.5, that means 1.5 inches in 1 second. And then 3, 4.5, that's going to mean 4.5 inches in 3 seconds. Then identify the unit rate, Unit rate means per 1. So the unit rate is 1.5 inches per second. Now we move on to example 3, modeling in real life. We have a robot vacuum. I also bought a robot vacuum recently. I found it at a thrift store for $15. Our family lovingly calls him Rick. Rick, the robot vacuum. He is responsible for cleaning the hard surfaces in the kitchen and the dining room. It's wonderful because you just push the button and he sweeps the floor. So this robot vacuum graph, it shows the area in square feet that a robot vacuum cleans in X minutes. Find the area cleaned in 10 minutes. In this situation, what we know is that the graph is aligned through the origin. The origin is the point 0, 0. We know that it's linear, it's a straight line, so we know that it has a constant of proportionality, and we know that it has a constant rate of change. It's going to change consistently throughout the entire graph. So therefore, we can write an equation that represents this relationship between area and time. Because the graph passes through the point 1, 16, right here, that's kind of a nice point. The unit rate is 16 feet, or 16 square feet per 1 minute. Unit rate means per 1. Okay, that's called the constant of proportionality as well. So an equation of the line could be written like this. Y equals 16 times X, because X stands for minutes. So for every 1 minute, the robot vacuum is going to clean 16 square feet. So we have a couple different things we could do here. We could make a table, and we could say 1 minute and 16 square feet. We could multiply both sides by 10, and we could get 10 minutes is 160 square feet. Another thing we could do is we could use substitution, and we could substitute 10 in for X. So Y equals 16 times 10, and that equals 160 square feet. And either of those strategies are going to net you the same exact answer. For this last question, the table shows the temperature Y in degrees Fahrenheit and X hours after midnight. Describe the proportional relationship between time and temperature shown in the table. So here's what I notice. For hours, for every time that we increase by 1 hour, we increase by 4 degrees. And that can be seen here as well. If we increase by 1 hour, we increase by 4 degrees. So this says, describe the proportional relationship between time and degrees. Or more realistically, in the real world, we would say degrees per hour. So the temperature changes by 4 degrees for every 1 hour. Knowing that, we can now find the temperature 3.5 hours after midnight. So an hour and a half is what we end with. So if we add another hour and a half, that's going to take us to 2.5. And we add 4 more. Let's add 4. So that puts us at 52. Now we add 1 more hour. That puts us at 3.5. And we add 4 more degrees, which puts us at 56 degrees after 3.5 hours. So that wraps it up for Chapter 5, Lesson 5. Let your teacher know if you need any additional support on any of these questions. Good luck with your homework. Check out the homework help video if you need help on that, and we'll see you in class next time.